echinoids, and I like echinoids. Let's just click through our videos, see what we've got here. So here we've got a couple of nice things about the echinoids. Now we already did the pedicelaria of echinoids further up here. There we are. And you'll see there are three-sided ones on some kinds of echinoids, not on others. Shown down here is just a beautiful picture of the sea urchin mouth. It actually has these 5 long teeth that are kind of like beaver teeth. They keep continuously growing and sharpening themselves, and you will just see them pinch into the center all at the same time. And it's just taking a bite. It's just taking a bite from 5 directions at once. Really interesting. Down here you can see sand dollars, which are echinoids. They're just a sort of a flat version of an echinoid. And you can see them feeding. They like to burrow under the sand and hide there. But yeah, they're very similar to other echinoids. This is a sea biscuit, not the stupid horse. This is the actual creature, which is another kind of echinoid. It's a thing called a heart urchin, would be one way to describe it. And this is it from its early stages, from fertilization actually, all the way through its sort of early juvenile stage. And this is a fascinating watch. I think I show this in biology too, just as an evidence of development in the whole process. But it's really something. And you can see the little Pluteus larva floating along, its little spiky self. And you can see it as it goes through these not evolutionary, but developmental changes, rather, that look like the different evolutionary steps. And you can watch it become a little tiny echinoid. Really fascinating. Watch for the development of the tube feet and the mobile spines. And shown down here is the similar thing, but with sea urchin development. So you can see how those are a little bit different. And it's, I think, a shorter, but also very interesting look at this. Fascinating group of creatures. All right, let's turn on the PowerPoint and go from there. Hello. So these are echinoids. And so that's the top of one echinoid. And so they're going to have that madreporite pretty much dead center on most echinoids, although it can move around. There's different kinds, and they're going to move their anus and mouth relative position around to different areas. So these will have an anus that comes out right next to the madreporite and a madreporite that's right next to that. And so those are both different ways to get rid of waste. And it's going to have those little ampullas and little tube feet down here, just like in everything. But the tube feet are going to wrap around. So the ambulacral grooves are going to wrap around this big ball-shaped body. So think of it as something like a brittle star, where you have that central ball of a body with these little plates, much simpler design on the plates. And then you're going to have, instead of 5 arms that stick out, the 5 arms are going to be embedded in the surface of that plate. They're going to feed food around and down and into the mouth, and also be used for moving around and grabbing onto things and all the things that a echinoid has to do. There are a few that have pedicelaria, little pincer-like claws on stalks. And they have lots of spines that'll have a ball and socket joint with the rest of the thing. So each of the centers of these plates is the socket, and then the ball part would be on the actual spine. And that sort of slots into there, and they can wave them around. They have muscles hooked up to the bottom, and they can rotate them in any direction. On the inside of them, what you can see here, this is actually their feeding structure. They call it the Aristotle's lantern, which is a kind of a dumb name for it, but that is what it is called, at least in the popular literature and some of the scientific literature. These are actually the teeth and the bones where the teeth come from. So the teeth are these little pointy things that come out, and we're going to keep regrowing our teeth, and they're going to keep feeding out from here. And these are going to do the biting and tearing food into pieces, and it's going to go in and it's going to start being digested right on the inside of that, which is the mouth. So these are irregular echinoids, or you can call them heart urchins is another way. They are not going, they're going to be more compressed and not as round and not as close to 5-fold symmetry. They are really definitely just 2-fold symmetric. But here you can see the ambulacral grooves, and they're quite easy to pick out. And on these little holes on each side, this is where the tube feet would come out. They're very small and clear, a little bit difficult to see. And here's another one. So on the test, on the skeleton of an echinoid, there are going to be at least 2 holes. So the apical disc at the top is going to have the madrepore. That's usually going to be right over here. And these are going to be little things called gonopores, if I remember correctly. They are where it's going to release the babies. Then there are going to be two other big openings. One is going to be called the peristome over here. That's not really an opening. That's just where the shell is broken, if I remember correctly. So the peristome, like stoma, that's going to be for a mouth. And so there's eating, and so look at that. That's going to go along scooping and eating. And the periproct is where the anus is going to be, and this is where all that food is going to come out that has been digested and discarded. And so echinoids also include the sand dollars, and here's a sand dollar in the process of burying itself. When they are alive, they do have that outer layer. So if you see a sand dollar for sale somewhere, what you've got is the boiled skeleton of a sand dollar. You've got the middle layer of it, and you're missing the outside and the inside and all the parts that made it alive and move around, and that's kind of weird, yeah. Why would you want that, you big weirdo? As you can see on these, it's like a regular echinoid, but that has been squashed flat. And so you're going to have, these are 5 ambulacral grooves. These are going to be used for moving things around and for burrowing into the sand. And then they're not really going to connect, but there is a little groove down here. So if we do catch some food up here, we can theoretically feed it around the edge. And then on the bottom, this is the super wide ambulacral groove. And there we're going to go back and have proper ambulacra, and they're going to be pushing the last little bit to move the food in toward the center. So it's like an expanded ambulacrum that runs around the side. The peristome is going to be in the middle, and the peristome, or mouth hole in the test, is always going to be at the center of those 5 ambulacra that are feeding in, because the 5 ambulacra are going to be the conveyor belts feeding in food. And the periproct is going to be the anus, and so it's going to be actually on the same side of the peristome, same side of the organism, rather, as the peristome in a sea urchin. And you see this interesting thing. There are different kinds of relatives of sea urchins, and you can actually watch them developing. The first ones to develop are going to be things like echinoids, at least of the echinoid class. They'll be similar to those regular echinoids with the spines that stick up and rotate around. But over time, we start to develop these other kinds, and we actually have examples of all of these now. These are things that live partially buried in the sand or completely buried in the sand, and what you can see is an anal migration. How cool is that? So the mouth starts out at the bottom, there we go, and the anus is at the top because these guys are living on top of the surface, and they want to get rid of their waste and get it as far away from them as possible. So they just put it up there, and the current will carry it away, and they can continue on eating and pooping at their leisure. Here are ones that are kind of halfway buried, and so they're going to have the mouth down here at the bottom so that they can eat things in the detritus that they're moving through. But they're going to have like a little snorkel anus that comes out on the top and actually, can vent this to the outside because they don't want all that gross waste to be trapped inside with them. There are some transitional forms where you can see the anus actually moving a little further down, getting toward the edge. And then in some of the modern ones, like the sand dollar, you can see that the anus is actually migrated all the way around, and so you have the anus lined up right next to the mouth. And so now it's going to be direction. The creature is going to move this way, and so the anus is going to be toward what would be the back of its movement. And it's going to try to keep going forward so it doesn't run over its own poop, essentially. So here's a nice little look at them. So these are the pedicelaria down here. This is a little threefold symmetric pedicellarium. And here are some more, and you can see the little pinchy teeth in there. Here's a nice long tube foot sticking up, so they have to be at least as long as the spine so that they can still move around and pass food around. And the spines are here to wave around and basically say, don't mess with me and don't eat me because I am covered in spines. If you were to flip it over to the underside there, you can see the, this is a regular echinoid, by the way. You can see the mouth with those 5 little pointy teeth. And just like you saw in the video, those little teeth can be extended to chew through the toughest things. And echinoderms like this are going to move along the bottom, just scraping with those 5 teeth. And they can grind through whatever is down there. They can grind something off a rock. They just strip the surface of the rocks and the seabed and the coral reef bare. And when there are a lot of fish around or things like otters around, then they will pick these sea urchins up and just crack them open and eat all the delicious insides. Echinoderms make great sushi. It's called uni, if I remember right. And it's gorgeous. Yeah, I've had it several times. But that's going to be the gonads of the of the sea urchin that are going to be served up there on rice with a little wrapping around them. And they're delicious. You should try it at least once. This is a different kind of echinoid, so this is going to be a thing called a pencil urchin. It just has wider, stronger sort of spines. And if you were to close up in on that, you'd see the smaller things like Pedestal Urchins and the tube feet down in there. Here's a more typical version. There you can see some of the tube feet are these curving things that are sticking up to the top, and a bunch of spines that move around. And these things really hurt if you step on them. They are extremely common in the Mediterranean because we've overfished that thing to the point where most of their natural predators are not going to be around or going to end up on somebody's dinner plate. And so the echinoderms just multiply and scrape everything off the rest of the reefs. And yeah, they're having a great time. The sea urchins are doing really well in the Mediterranean. They're mostly it in terms of what's doing well there. Here is a flat sort of sand dollar, and this is a sea biscuit with its madreport at the top. So in the sand dollar, the anus is actually going to be on the underside right about here, and you can see they'll actually have a groove on some of them that will allow the waste to escape. And so this is going to move forward, this is going to be the back, this is going to be the front. And here you can see they have the ambulacra, and they will sometimes have a little hole there so they can just pass food down to the bottom where the ambulacra pick up again and into the mouth. So it's a neat little, yeah, it's kind of like playing pool. It's going to or playing putt-putt maybe, put the food down in the little hole, pick it up on the other side, and finish out and take it all the way into the mouth. This is a close-up of one of those spines on an echinoid, and you can see all the layers on here. They're really fascinating. It's still that stereom skeleton. And echinoids are very much about sort of light and strong rather than sort of rigid and dense and strong. So if you saw something like a Tyrannosaurus rex bone, these would be extremely solid because they have to hold up a ton of weight. Echinoderms live underwater, at least these guys do, yeah. And so they don't have to worry about holding up a massive amount of weight. They just have to be able to stand up when something tries to bite them. And so this is how they do it. This is the way that they work. And you can see the little muscles in here that control the direction of the spine. And they can wave these spines all around. And yeah, they can use them to defend themselves. It's just like it's covered in swords, basically, and constantly moving them around. Yeah. Very, very tough little echinoderms, and echinoids in particular. Okay, if you were to strip away all of that skeleton, this is what you would see on the inside. So we've got our esophagus here. We've got the teeth are going to be pointed down at the bottom. These little canals are going to lead to the ampullae. They're going to run each of the little tube feet. The tube feet do come out of that ambulacral groove. So this is on the inside, but it's going to be reflected on the outside in the form of a tube foot. And once again, they're going to be ampullae, and they're going to operate with little tiny muscles that contract them down and squeeze the water out because they are hydraulic creatures, fundamentally little hydraulic creatures. Here we have all the little fleshy muscles that move the teeth down. Here's the bottom point of the tooth sticking out, but the tooth is actually very long and keeps growing. And so as they grind off the ends of their teeth, they just keep growing more and just keep chomping. Yeah, that's how they do it. And here's the whole thing kind of put together. So our water vascular system is going to come up here. We're going to collect all that waste through the axial organ and into the water vascular system. We're going to vent that out through the madreporite. The genital pore is going to be hooked up to each of these gonads. These are the delicious tasting, I can assure you, gonads. And they're going to run down underneath where each arm would be. So there's going to be five-fold symmetric gonads, in addition to five-fold symmetric ambulacral grooves for the most part. Here is our little ampullae. This is the water vascular canal that's going to operate the tube feet on the outside. And here are the plates in between. They're going to have those spines sticking out of them. And different echinoderms will have different spines. The brain will run in a ring right down here around the bottom. This is the nerve ring. And there are going to be 5 big branches of the nerve ring that would go out to the arms if this was a starfish. But since it is not, since an echinoderm is like a starfish with the arms folded up over itself, they're going to run up each of the sides along the inside of this. And they're going to run the tube feet on each of the 5 sides. But essentially pretty much the same as before. Here's a really primitive one, but it shows off this the form very nicely. So this is a regular echinoid. And here's going to be our anus in the center. The apical disc is going to be here, so your madreporate would be in that sort of region. You can see it's not quite five-fold symmetric, but you can draw a line of symmetry right up there, and you can pretty much get to two-fold symmetry. It's actually not even perfect two-fold symmetry, if you would believe that. Here's our ambulacral zone, and so the tube feet will poke out through these little holes in the test. And this is the intraambulacral zone. So this is where those bases are going to be. They're going to hold on to the spines. They're going to socket right onto there. And in between, this is where the pedestalaria would be in this kind of field in between there. The tube feet are going to come out of the grooves, out of the ambulacral grooves themselves. There we go. Those are the echinoids, and I hope you enjoyed that